Scatterplots and linear correlation is the first worksheet we're going to talk about today. Correlation describes a linear relationship between two sets of data. Okay, what's our objective today? Interpret correlation of scatterplots. Well, before we can interpret correlation of scatterplots, we need to know what all that means. Do you know what interpret means? Interpret? Figure something out, right? Correlation? If we don't know what that means now, we will by the end of this worksheet. Okay? And a scatterplot. Do you know what that means? So today I will interpret correlation of scatterplots. So the only word we really have trouble with there is correlation. Well, guess what? That's what we're learning about. So let's make sure we understand it. Okay? Correlation, oh good, describes a linear relationship between two sets of data. So a correlation is a relationship. Okay? The correlation can help to analyze trends and make predictions using data. Linear correlation describes the linear trend of the data. We have to be careful here. I know what it says. I know that you can read, but sometimes there's not 3, there's 5. Okay? Depending on what kind of worksheet we're looking at. Yes, positive, negative, and no, like you can see on your worksheet here. But sometimes there's strong positive and weak positive. Strong negative and weak negative, and no. Do you see how that makes 5 instead of just 3? Okay? So, let me give you an example of what I mean. If I'm going to compare these two sets of data right here, if there's my data, can you tell me which one of these is strong positive and which one's weak positive? The right one is strong, the left one is weak. Are they both rising to the right? Increasing from left to right? So then what makes this one strong positive and this one weak positive? It's more compacted. They're much closer together here, right? It doesn't matter that they're steeper. It doesn't matter. What was the other thing you said? Steeper? Okay, it doesn't matter that they're steeper. It matters how close they are. When they're really, really close together, that's going to be strong positive correlation. When they're still positive, when they're still rising to the right, but they're a little bit more scattered out, that's going to be weak positive. Okay? And in certain situations, this would be strong positive if you compare it to something that's even further spread out, isn't it? So it really deals with how the dots are related to each other. Fair enough? Okay, so why is this called positive correlation? Don't read me the words. Tell me why it's called positive. What's rising to the right? The dots. If there was a line through them, what kind of slope would that line have? Positive. Draw a line through those points. I'm not saying play dot to dot, even though it would make a hot dog, probably, right? I'm saying draw a line through them as getting as close as possible to all the dots. Does your line look exactly like mine? No, because we are human, right? We're humans. We are different human beings. Should our lines be relatively close to each other's? Yes. Okay? So when I draw a trend line through here, it creates a line with a positive slope. That's another way you can think of positive correlation. Okay? So negative correlation. Draw a line through these points. Why is it called negative correlation? 2 reasons. It's decreasing from left to right. What's the other reason? If we drew a line, it would have a negative slope. The line would have a negative slope. Okay? No correlation. Go ahead and draw a line through these points. That's a really good question. Where? For me to get a line that's as close as possible to these points, if I ask you to draw one, we would get a lot of different lines. And why? Because there's no linear trend. They're not heading in any particular direction. We could draw a circle around it and it would look like a chocolate chip cookie. But that's mostly only because I want a chocolate chip cookie. Okay? Any questions about what correlations? Okay. Turn to your next worksheet, please. Analysis of linear data. When real-life data is collected, the points graphed usually do not form a straight line. Usually, sometimes they do, but most of the time they do not. Data points may show positive linear correlation, negative linear correlation, or no linear correlation. If there is a linear correlation, a linear relationship can be approximated. Okay? That approximation is called a trend line or line of best fit. Now, for the record, that sense is not exactly true. Okay? When I was in college, we had to find the lines of best fit, and there's some very, very specific rules about drawing a line of best fit. How do we draw a trend line right here? We just kind of drew it, right? Okay? So if you're around a bunch of mathematicians and you want to see a bunch of mathematicians fight, say that sentence. You'll have a big math fight on your hands. Okay? Which can be entertaining in and of itself, but we don't want to go there, right? Okay? A trend line can be used to make predictions. Okay? So here's the table. It's talking about Wings Incorporated and the flying time and the mileage from Chicago to other cities. It's got the miles and time in hours, hours and minutes, and it's got the distance in miles. Okay? So, first thing it asks us to do in part A is to make a table of miles as a function of time. Well, I don't know about you, but to me this is a table of miles as a function of time, isn't it? Miles is the y value, time is the x value. But if you read that sentence a little closer, it says make a table of miles as a function of time in hours. Only hours, not hours and minutes like what's given to us. Okay? So the first thing we need to do is readjust these values in our x column. How much of an hour is 10 minutes? 1/6, but I need a decimal approximation of that. Do you know a decimal approximation of that? Let's pretend that you don't, so I can show you how to find them. Okay? Turn your calculator on. I want a new calculator sheet, a new calculator page. So I'm going to hit Home, New Document, Calculator. Okay? So I want to say 10 divided by 60. Now sometimes I think these calculators are smart alecks because if when I say 10 divided by 60, look what it tells me. 1/6. What do I want? I want a decimal. So watch this. 10 divided by 60, except I'm going to press Control, my blue button, Control, Enter. What does that tell me? Oh, I accidentally forgot to press Control. That was my fault. Control, Enter. Did that tell me what I wanted? Look what Control, Enter means. It means approximately equal. So a decimal is okay there, right? So if you want a decimal answer, you're going to have to press Control, Enter. Does everybody understand that? Okay. Now, why did I only put in 10 and not one, like something with the 1 here? Isn't the 1 already in hours? So really what I have here is 1.17. Right? I even adjusted the brightness this morning so you could see my pencil, and it was working fine in second period. I'm sorry it's light again for you guys. Okay. So what am I going to do on the next one? (41) divided by 60. Why am I dividing it by 60 to begin with? 60 minutes in an hour. Very good. Control, Enter. So I get 3.68. And because I want to work smart, I notice down here at the bottom I have 1 and 41 minutes. Isn't that just going to be 1.68? Yes? Okay. So let's find the next one. 29 divided by 60. Control, Enter. So we have 3.48. 20 divided by 60. Hopefully you don't have to do this one, but if you do. So 2.33. Oh, but look at that, how nice that is. 4.33. Oh, look how nice that is. 1.33. So I just have 2 left to do, right? 27 divided by 60. Control Enter. 2.45. And 21 divided by 60. Control Enter. 1.35. Now, you know how I feel about blank answers, right? So it says, make a table as a function of time and hours. For example, enter these points into the graphing calculator. Okay. Let's go enter them into the graphing calculator. Do you know how to do this? You do? Can I show you in case there's somebody who doesn't? Home. I need a new document. I don't want to save my old one. Where do you think I'm going to put this stuff in? Where? What am I allowed to enter into a graph? Only y equals, right? What is this? Isn't this a list? A list of numbers? Wouldn't I put numbers like this into a computer, into a spreadsheet program? Okay, so let's go make a spreadsheet. Hey, look what this looks like. It looks like a spreadsheet. Now, I hope that you came to class today prepared to have your mind blown, because it's about to be. Okay? First thing I want you to do is arrow up all the way to the A box. Not this one right here, all the way to the top. Okay? What is the name of that column? It's really called column A? Is it really called X? What's it really called? Time, right? That's our time data. Hey, how about if we just call it time? For real. Notice when I'm typing it in, what kind of text do I have? Italics, but when I press enter, look what happens. OMG. Okay? Now, the calculator has stored that title as this list. Sometimes we need a column of X and a column of Y, but sometimes, most of the time, doesn't it make more sense if I call it what it actually is? Doesn't it make it more real to us? So what's this one called? Distance. It's like texting? Who? Like your math girlfriend or something? Okay. So let's put in our data points now. Okay? Press enter. Don't press tab. Tab will take you across the page and it gets kind of confusing. Okay? So I guess you can press it if you want. Just don't complain to me. Okay, do you have all your data in? Yes or no? What do I really want to see about this data? What's my objective for today? What am I trying to see? Today I will interpret correlation of scatter plots. So what do I really want to see? The scatter plot. Don't do, just watch. I promise I'll give you a chance to do in just a second. Okay? Just watch. I'm going to press Control Doc. What's that going to do? It's going to add a page. What I want to add is a data and statistics page. Because if I just open a new document, first of all that stuff I just created is gone. But if I add a new page of a data and statistics, it's going to use the information I just put in my spreadsheet. Does that make sense? Okay? Okay. That doesn't really make sense. It's just a bunch of random dots. But watch this. If I remove my cursor around here to the bottom of the screen, it says click Enter to add a variable. So I'm going to click on it. What is my X variable for this problem? Time. Enter. Oh my gosh. Is that the only variable for this problem though? What's the other one? So along my y-axis, I need distance. Oh my gosh. Put your brain back into your head because it's seeping out of your ears a little bit. Okay? This is a very dynamic graph. It's not a static graph. It doesn't stay still. It's dynamic if I need it to change. Okay? So, it says make a scatter plot of the data. Okay. Does it show linear correlation? Yes. Now, at this point, we're going to be slightly rebellious as a group. We're going to do a line of regression. Okay? Again, you guys have done lots and lots of scatter plots throughout your high school career. And even from junior high, you did scatter plots in there. Okay? I'm confident that if I gave you a piece of graph paper that you could make me a scatter plot. We need to be able to go a little further today, so we're going to let the technology do that for us. Okay? So I need a line of regression. Do you know what a line of regression is? It's the calculator taking the data that we just found and actually finding the very, very, very best line of best fit. Very, very, very best trend line. Okay? So if we're looking at our calculator, how are we going to find this line? What do I press first if I don't know what to do? Menu. Press menu. Do you think one of these options will give me a way to find my line of best fit? Or my regression line, excuse me. And if you don't know, what should you do? Maybe guess? Are we trying to find out what plot type this is? No, we already know it's a scatter plot. Do we know the plot properties? No. Actions? Are we trying to do an action? Maybe. Go there. Is there a line of regression here? No, so that's the wrong place. Go back. Are we trying to analyze the graph? Sure, maybe. Oh my goodness, regression. So go down to regression and hit right arrow. What kind of regression are we trying to find? Linear, which one? MX plus B. When I choose it, oh my goodness. Not only did it draw it in there for me, what else did it do? It gave me the equation. I don't even have to go find it. Okay? So right here beside where we changed the direction to do a line of regression, let's write our equation right there. Okay? Y equals 455. What is that? 455.825x. What sign goes here? Plus a negative? Can I put plus a negative if I want? Can I put minus if I want? So there's my line of regression. Okay? A, find the slope. Well, if I have my line of regression, where's my slope? It's sitting right beside my x. Okay, so 455.825 is my slope. M equals. Where's my y-intercept? B is negative 257.11. Very good. Any questions on finding those? We're not doing 4 or 5. Turn the paper over, please. Part B. In flight situations in the real world, distance is usually the independent variable and time is the dependent. What? People know how far they're flying but would like to know how long it would take to get there. Does that make sense? Okay. Does time usually depend on distance? Not really. Okay. Time is almost always the independent variable, isn't it? But this is one of those situations where time can be the dependent variable. Okay. So, number 6. Make a table of time as a function of miles. Well, what did we have before? We had miles as a function of time, and it wants us to have time as a function of miles. Just flip it. Okay, do we need to re-enter those points in the graphing calculator? No, and I'll show you why in just a second. So, okay. Set up the scatter plot so that the independent variable is miles and determine if the data shows linear correlation. Are you ready for your mind to be blown 2 different times in one class period? Watch. I'm going to click on that. What do I want that to be instead? Distance. Oh my gosh. It flipped time over here by itself. Holy cow is right. Okay. Now, first of all, I need to make something very clear to you. Okay. Is this the same line as that we had a minute ago? Does it look the same? Yes, it does. So I need to make sure that you understand that these are different lines. Okay. I'm going to go back here and change this back to time so we can look at it. I want you to be able to compare this to one in front of you. Do you have yours set up as distance and time? Okay. Does it look the same as the one on the screen for you? Yeah, it does. What's different then? Compare and contrast them. What's different? How do we change on the x-axis? Point 2, right? Aren't we changing by point 2? 1, 1.2, 1.4, 1.6, 1.8. How are we changing on the y-axis? Yeah, slightly different. 200s? 400, 600, 800, 1,000? Yeah? Now, how is yours different? Go down here, change it to distance if you haven't done it already, and tell me how it's different now. The time is, first of all, it was on the x-axis, now it's on the y-axis, and how are we counting? On the y-axis by 2s. Remember, on the y-axis last time we counted by 200s. On the x-axis, this time we're counting by 200s. Last time we were counting by 2/10ths, right? By 0.2. Does that make sense? So while visually it looks the same, do you understand that they're not the same line at all? Yes? Okay. Determine if the data shows a linear correlation. Does it? Yes. Find a trend line. Regression line. Oh my gosh, when I move my variables, look what happened. It changed my trend line for me. So let's write that equation for number 8. We're not going to do number 9. What about number 10? What's the slope? What's the y-intercept? Good. What you have left to do is 12. Questions? Have a good day.